Okay. Welcome to the Meltzone Podcast from July 14th, 2019. This is episode 18, and I'm Tom.
And I'm Stefan. And on today's episode, Tom will talk about his recent trip to Prague Maker Fair and how he really enjoyed the spirit of all of the makers around there. He was also experimenting in the last couple of days in topology optimization and how he could use generative design in order to create really nicely looking shelf brackets. I just received this week a kind of expensive 3D scanner I have for my disposal for the next couple of weeks, and where I want to make some really nice projects with it as long as I have it. And I just started with a filament test again, and I talk a little bit about the experience I had in terms of how is the strength of the layers or how is layer adhesion affected by part cooling and temperature.
In the news section today, we talk about puppies because that's kind of the hot topic in the 3D printing community today. Also, why have resin printers become so popular? We've been seeing a lot of the Elegoo Mars, the formerly RapRap Pro resin machine, just used by people everywhere. It looks like Twitter is blowing up just on that one single resin printer because it's cheap. It's really cheap and accessible. And also in something that we both think is kind of really cool, printing on diffraction grating sheet. So yeah, that's a really interesting effect that you can achieve with that. That's something that David Shoreys is doing. And for the topic of the week, the Edelkrone Head, the 3D print at home augmented with nicely machined parts. Is it actually something that is just a marketing stunt, or maybe other manufacturers could pick up on it and use for their own portfolio? All right, we're back. Stefan, well, it's been a while. It feels weird.
Yeah, it feels really weird. We haven't been properly talking for the last 5 or 6 weeks.
Yeah.
So
with Maker Faire Prague in the middle there.
So the last podcast was already I think 1 week delayed, and then you did it with Joel and Joe at Prague Maker Fair, which was really nice.
Yeah, it was great hanging out with those folks.
Yeah,
and of course, Prague Maker Faire. I guess we should add that to our topics to discuss. But that's been a really nice Maker Faire.
Yeah,
I did mention that in that episode, but it was eye opening.
Yeah,
having kids there and having everyone just involved. Really nice.
I really envied you being there. I was kind of upset that I wasn't there, because also for me it would just have been like a 5-hour car ride, something like that.
I mean, you would have driven straight past me. We could have gone together.
Yeah.
You would have, your alarm in the morning would have been at like 4 a.m. But
in my case, I think I wouldn't have done it in just one day, because I guess for you it was also really busy.
It was actually pretty good. The Maker Faire itself isn't that big where you actually need to spend 2 days. Like you've seen pretty much everything in a day. Of course, if you add stuff like a factory tour at Prussia or a podcast recording or that sort of stuff, it does get busy. But for me, it was actually super relaxed in a day.
Yeah. Yeah, I've never been to the Prussia headquarters, and they have been growing just tremendously. And I need to go there at some point and just take a look at the factory. It's just impressive to see. Yeah.
Yeah, have you seen Joel's factory tour?
Yeah, I have seen it. It was really nice. And would also I really enjoyed watching the latest Prussia 3D video, where it wasn't the latest, but where they talked about the history. Yeah, the documentary about Prussia. It was so impressive to see where 2 guys started in their dorm room or something like that, and just 5 years later they have a company with 400 employees. How many employees do they have?
Many, very many, but 400 plus. I think that's pretty accurate.
Yeah.
Yeah, that they were at the right place in the right time with the right mindset, and just worked out.
It's really interesting to see this tweet, which maybe started it all, where Joseph Prussia said, okay, should I buy one of these, like, I don't know, tablets for making music, or should I buy a 3D printer?
Yeah.
Maybe if somebody else would have read that at first and convinced him to buy one of these music tablets, Prussia wouldn't be around, and maybe I wouldn't be here.
Our lives would be different.
It would be different. It's really, really interesting.
I don't know if anyone else would have stepped up and taken the place that Prussia is in, but...
Yeah, maybe, but they really gave the whole community and the whole thing around 3D printing such a boost. Even though I think like Creality and all of the other Chinese manufacturers, they are selling way more 3D printers.
Oh yeah, for sure.
Prussia is the one that made it simpler, and they invest a lot in researching of the technology. So lots of the things we see in like current Chinese 3D printers was kind of out of their research lab.
Yeah, I mean, pretty much all the printers you can buy, including the Crealities, are kind of based off the Prusa i3.
Yeah.
Still.
Yeah.
All right, but we tend to derail into these Prusa praise runs here.
But just one last question. You talked about all of the kids being there. So how did you feel? Is the Prague Maker Faire different to other maker fairs where you have already been?
So, okay, what can I compare it to? I can compare it, of course, to the 3D printing shows, the actual, FabCons, etc., which are trade shows. I mean, those are totally different. The Make Munich, the local one here, is kind of a big mix of both. But it's actually more of a trade show than a maker fair. The big one in San Francisco Bay Area, which may not ever happen again. I think that was also more of a trade show than the Prague Maker Faire. So it was a really hands-on, really almost every booth had something where you could get involved, where you could just as a kid, or Joel pointed out, he had like this little blown glass vial or whatever that was,
his crack pipe.
Yeah, his microbong. You could do stuff like that. Prusa had like a huge thing where kids could make the Pinewood Derby cards, basically with 3D printed cards, 3D printed parts and all that. There were like small robot arenas. There were stuff, those two wheels of death, those fire spitting ones. You don't see in the while you make video, you don't really see the fire, but everything was like full of people and full of people making things. And I think that's something that I've not seen on any other show to that extent.
Okay, where you really see the spirit of making and not just companies showing off their products want to sell something. You see, are you still there? Oh,
I can still hear you.
Yeah, sorry. I think my headphones are currently running out of juice. Just give me 1 second.
Hello.
Always check your gear before you start.
Yeah, those kids with their fancy stuff.
Okay. So as a recommendation, if you guys are living next to Prague, people should go there.
Yeah. I mean, in general, the Czech folks, they do speak and understand English pretty well, I think.
Okay.
They're just really shy talking. That's been my experience, especially when you shove a camera in their face. So the Prague Maker Faire has always been one that I don't bring home any interviews or any content that is actually interviewing and talking to people. But as a visitor, you can get along pretty well. Cool. Even if you don't, if you're not a native Czech speaker.
Yeah. Cool. Pretty nice. So I have seen a tweet from you yesterday where you did some topology optimization.
Yeah, all inspired by your videos, actually. Otherwise, I probably wouldn't even know that stuff exists. And I was like, where do I find this? Oh, you click into simulation. So I worked my way through your guide, and I created some topology optimized designs. So these are shelf hinges because I need to hang some shelves. Basically with the constraint, okay, this base shape, you can kind of see what the original shape is supposed to be there. And then there's a 35 kilograms, so 350 Newton load on here. And these two holes are fixed, which of course isn't like totally accurate, but yeah, that first try, second try, slightly different look. I mean, these all probably work. It's just about, which one looks the coolest. With an additional constraint that the back here is actually a sliding mate. So I thought that would help it like rest and push itself against the wall. So I think that one actually looks pretty cool, and they're all quite printable. I printed these like that, so they're probably going to crack right there. But we'll see. I'll break these. These are 50% scale.
Okay.
And then I did another one, and this is, I think, the same parameters as this first one. But this one is like a much higher resolution model. So same settings, same everything. You can see kind of the same trough they created back here, but like thick branches up here, thinner branches, and this is actually a bifurcated design where there's this front part is hollow and there's two sidewalls. This stuff actually looks super cool. I gotta say, you see the models, they look super rough and janky and all, but once you actually print them, they're like this alien technology stuff. I really like the look.
Organic structures. Yeah, this was the question I got a couple of times on my video. Why did you, take the effort and redesign this, the result from the topology optimization? And that's always the question. They look pretty cool, but I think they're just not always optimal to print because you don't really take any manufacturing constraints into consideration.
Yeah. So again, these are going to sit like that on the wall, but I had to print them like this because then the overhangs kind of work out. I originally wanted to print them like that, flat against the table, but of course I'd have to, fill all this stuff with supports and then peel it out between the arms. And that's just not going to happen.
Yeah.
Now in Fusion 360, in the paid professional version, there are two types of generating shapes like or designs like this. There's the topology optimization, where you start with a block of material and then it removes everything that it doesn't think it needs. Or that's the topology optimization. Or you have actual generative design, where you start with just the mounting points and the surface where it contacts other stuff, and then you tell it, okay, do your thing, create some features, create some geometry. And there you can actually tell it, okay, I'm going to machine this on, a subtractive milling process. I'm going to do this with molding. I'm going to do 3D printing like that. Please account for overhangs. And there you can actually set it, okay, maximum overhang angle 45 degrees. And I think that would be a better process for this, but it's not included in the enthusiast license for Fusion. So I don't have access to it, unfortunately.
Yeah, that's pretty sad. I also really wanted to try the generative design in Fusion, but I also don't have access to it at the moment. Actually, I think the main difference between the generative design and the structural optimization, as you also did it in Fusion, is that it's just a little bit more advanced, but you still have to design your design space and your non-design space, and you add to your constraints. But setting up different load cases, setting up different parameters, including manufacturing constraints, that is also that is everything which is included in the generative design suite, and that is pretty interesting. And topology optimization and generative design has been hyped over the last couple of years, especially with 3D printing becoming more and more common. But as I also tried to point it out in my video, it's not always the perfect solution, because
you literally say like, don't print the geometry that it generates. And these are literally the geometry that comes straight out of, there's a small fix back here because this is such a low resolution model that this one arm kind of didn't like materialize. It was like two vertices. So
for artistic purposes, I think it's great. And this looks so cool on a wall. But in terms of in terms of that, it really makes sense in a mechanical point of view, if you take into consideration material anisotropy, so that material behaves different in different printing directions and things like these. It's just not really that perfect, but it is a good It gives you a good idea how you could design your structure, and you should take that idea and then think about how you could design it in a maybe even better way. But
yeah, like what you see with both of these is, okay, apparently this piece of material right here against the wall is not needed. Like it's not doing anything for structure. You need kind of a cross brace towards the middle of this area.
Exactly.
Oh, you're not seeing that. Towards this middle. And of course, this up here, it looks like the simplest thing to do is to do like a 2-part V shape that goes from that center beam up to the surface. If, of course, your load case is correct, and this is actually an evenly distributed load on this, which of course it's not going to be because there's a piece of wood sitting on top. But yeah,
it's cool
if you want to do that. You've been how complex of a project have you been running through that?
I haven't. Well, in Fusion 360, I haven't really done highly complex structures. I have been doing highly complex projects in ANSYS and OptiStruct and the commercial products at work, but Fusion is kind of limited. So even designing separate load cases, that's sometimes kind of a hassle, and I am currently not really understanding perfectly what's going on in the background, so it makes it hard for me to really interpret the results properly. So I stayed away a little bit from that.
It's a really simple and intransparent kind of process that's happening. The main issue that I've been having is that, as it's an Autodesk product, it doesn't always complete. It doesn't always work. And especially with this load case where you have more than a single load. I actually tried a multi-piece design where there was an actual plank on top here that then had the load applied to it. So a rigid plank. So you actually get that case. And that either never completed. I let the simulation run. This simulation runs on the cloud. It doesn't run locally. I wish it would run locally, but you can't do that. So this one took 20 hours I had it running, and it never completed. It's like the progress bar in simulation. It's just at that last 90% mark, and it never finishes. Also simulations that are a higher detail, because these are pretty rough. Like you can see the arms are actually really coarse. There's a lot of chunkiness there. Those tend to not complete. Then I got errors of the simulation running out of memory because of a 32-bit memory limit, I guess, 2 gigs of allocated memory, which is apparently an error from the server side, because I'm sure my computer does have enough RAM. So I really wish it would run locally, because I think my video editing rig could handle that just easily, and you'd have more control over it. I don't know.
There are unfortunately not many other free solutions around. There are a couple, because actually the process is not too hard in the background, so on the numerical side, but the implementation is always the problem. And the implementation in Fusion 360 is straightforward. It's just a couple of clicks and you get a model, you get a result in the end, but you can't really control it finely. And if something goes wrong,
usability,
it's hard for you to debug. So I've been spending hours in, debugging outputs from commercial optimization programs, and I know if something is in there, I know what's wrong with the model itself. But right here, I always have to guess, okay, this constraint could make problems, or that contact could make a problem. It's nice for a start. It's really cool for things like these, and I've been looking forward to, or I thought about really making a quadcopter using this, and also maybe applying my how did I say, adaptive support structure, intelligent infill, adaptive infill thing.
Oh that one, right? Yeah.
But didn't do that so far. I just did not have the time. But cool,
right?
It's really cool that you're also
It definitely looks cool. Again, not sure how practical or realistic even these results are in being suitable for what I'm trying to do with it. But it's a shelf bracket. Come on, it's not life dependent. And I did give it a lot more force for the simulation than it's actually going to carry. So this, in full size, twice the size, is going to carry 10 full folders full of documents.
Yeah. But
theoretically.
This is something I gotta say at this point. The load you are putting on the model in Fusion 360 doesn't change the results. So if you put 1 Newton on there or 100,000 Newtons on there, the result will always be the same, because you are defining the material ratio that will be kept. A topology optimization always requires the recalculation or the verification of your design. Because if you have multiple load cases, the amount of load you have in each load case, or the ratio between the different load cases, they play a role. But if you do a topology optimization with only one load, you can apply 1 Newton on there or 1 giganewton. The result will always be the same. The result only differs due to boundary constraints and especially the material ratio you are defining. So keep that in mind.
That's so the thing I saw in Fusion 360 is, you get that nice colorful image, which of course people like because it's colorful and you think you've actually simulated stuff. Is that the color scale is on criticality, which he calls it. Yeah. So it seems to optimize to 50% criticality, which I kind of tend to read as a safety factor of 2. No. I don't know. There is a separate material reduction ratio given, which in these cases I think was around 31%, which I didn't actually define anywhere. So it always seems to optimize to 50% criticality. So if any of you listening or watching know what Fusion 360 is actually doing, let us know, because it would actually be good fun to actually know what the hell is happening here.
Yeah, just pay attention, because as I said, this is one of the problems with topology optimization. You always need the verification of your design, because usually you are defining a load case, you optimize for, you minimize the compliance of the model, which is maximizing the stiffness, and at a given material ratio. This is the setup which 99% of the models run. There are some tools and codes where you can also include a stress safety factor or something like that, but that usually gives you inconclusive results. So that's only rarely working. So yeah.
All right. I guess I'll just try it out. I'll give it another run with less force on here, and we'll see if that actually changes anything.
Let me know, and maybe even destroy one.
I mean, these were specifically printed to try and to destroy.
Does it hold a full tom?
I don't know. They feel very rigid.
Yeah,
but I don't think I'll actually. I don't know. Maybe.
Is it currently PLA that you've been using?
That's all PLA. It's all PLA. Because why? PLA is plenty strong.
Yeah,
and easy to print for these light parts like that. I don't need anything else for these.
And maybe also just one last thing before you continue. Topology optimization does not include things like a buckling constraint. So you need to do a verification for stresses, but also for buckling, because topology optimization can sometimes give you really slender structures, but these slender structures are not sized for buckling. And buckling, especially with these slender structures, is usually the failure mode that you're having. Give it a try.
Okay.
I might.
This small part down here, I've been looking at and was like, maybe this is gonna kink inwards right there.
I actually want to do something like that in the next couple of weeks, because coming to the next topic, I can finally reveal it, but I got a kind of expensive 3D scanner / cool measuring device, which was provided by GOM, one of the market leaders of optical scanning or optical, how do you say?
Right.
Metrology. They got me one of their 3D scanners for a couple of weeks, with which I can play around. And you can't only
for you as a YouTuber,
for me as a YouTuber. So they have seen my was my DIY tensile testing machine video, where I also talk about how you can use a camera and put a couple of points on your model and calculate the strain with these points. And this is something which is done, or which can be done with one of their systems. And they just reached out to me and said, hey, don't you want to not really work with us together, but we really find it cool what you're doing, and if you're interested, we can get you one of our equipments for a couple of weeks and you can play around. If you like it, you can do something with it, but no worries, we don't force you to anything. I have met them at the Control exposition a couple of months ago, and yeah, it finally arrived mid this week. It's a kind of small 3D scanner, kind of similar to the size as I think your Shining 3D.
So that's about the size of a Kinect.
Yeah. Mine is like the size of a small projector thingy. Okay. But it's kind of compact. It has fixed lenses in there, so the measuring volume is the same, and we'll see how it works out. I didn't really work with it so far that much, but this is something I want to do next week. And the thing is, you can't only do 3D scanning with this device. This thing has 2 cameras in there, so you have a stereo camera, a calibrated stereo camera, and you can just spray parts with a like dot pattern. So just take a spray can from far away and put tiny dots on your part.
Yeah, I actually got some specific spray for that.
Yeah,
just these days.
And so the thing is, then you can film your test with this camera / 3D scanner, and after that, or even live, it will show you the stresses the strains in your part. And this is really, really cool. And
how detailed is that? So can you just take a part like this, bend it with your hands, or does it have to be mounted, or what's the constraints on that?
It just needs to be in a measuring volume. And that's pretty cool because you can, usually things like these are done with strain gauges, where if you have a test, you put strain gauges at different positions and you get the strain at this location during the test. But this technology, which is called image correlation, gives you the possibility to really take a look at the strains in your whole part. And that is so cool. And the thing is, you can do that with the 3D scanner, but the 3D scanner is only able to do it at a frame rate of 5 Hertz, but they have dedicated systems for that, which even go up to like 1,000 Hertz or something like that. So you can do really highly dynamic tests and get the strains during this test. And this is so cool for me as an engineer, because before I had to put strain gauges on my part, and now I can just like film the testing procedure and get strains on the whole part. And then maybe even take these results and correlate them with my finite element model in order to be sure that my analysis I did beforehand is right. And then I can, in the future, use this finite element model to take a look at stresses at other locations, which I'm maybe not even able to take a look at with that camera system. Yeah. And this is something really cool. I'm really looking forward to do that. And I thought about a couple of applications or parts where I could do something like that. One is my test hook, where I also have, I think already a video on Twitter where I did it, because you can also use this technology with just like your standard camera and their software, which is available for free.
Ooh,
yeah,
that is nice.
That is really nice. Their software, so the free version, only gives you the possibility to do it in 2 dimensions. So also your load case needs to be 2-dimensional. Yeah. But if you have one of their scanners, or if you have one of their even more advanced camera systems, which are especially for that application, you can do that in three dimensions, and they even have high-speed cameras for that. And that is so cool. And since I tested Joel's filament drag design thing also quite a while ago, I thought about this would also be really interesting to put one of these scanners or to put these scanners on one of these parts, destroy them, and really take a look during the testing. Where do we have stress concentrations? Where does the failure happen? And if it and the question, and in order to answer the question, is it a like static failure of the part, so where the stresses were just too high, or if you have a buckling failure? And this can also all be done with that camera. And I have that for the next 6 weeks until I get on my summer vacation. So I really need to use it as much as possible.
Yeah, make good use of it. I mean, the image I've been having in my head for this entire time was like, you have a car crash test, and you basically point that thing at the collision area, and you get a real time, whereas 1,000 frames is a lot. You get a slow motion of how each individual part failed.
That is really cool. That's really fascinating. So as I said, I haven't been trying it out for that application so far, but I know that it works. And as I said, I need to find a couple of applications, and I really want to do a video about that. Not just to say this is a cool technique, but if you can even do that with kind of your phone camera. If you have an application in that direction, that your load case is kind of two-dimensional.
Yeah.
You can use the software and do this image correlation there and take a look at the stresses and things like these. It's really, really cool. And it's a cool technology.
Yeah, but it's also a 3D scanner.
It's also 3D scanner.
It feels like that's just but it also does that. But
no, it's primarily a 3D scanner, which is really cool because I wanted to have one for quite a while. This is not mine now because it's pretty expensive, but I can use it for the next couple of weeks, and I really want to take a look at things like, what amount of warping do you have if you anneal PLA parts? Because of course you can do really simple parts and take some measurements, but how is your whole part affected by it? Things like how precise are 3D printers in general, and things like these. So it's really, really interesting. I wanna just do a couple of things in that direction, and I hope I can capture a lot of stuff before I send the thing back, and maybe then afterwards release a couple of videos in this direction, which is really cool. So I'm really, really happy to have that device. I'm so pleased that they gave me that possibility. It's nothing sponsored. They just said, okay, we find cool what you're doing. You can have one of our scanners for a bit of time. If you do something with it, yay, that's fine. If not, that's also good as well.
Yeah, pro level hardware is always such fun to play with.
Yeah, it's great. And well, the software is really nice. It's not like I think, well, you've been using the Einscan a lot. It's sometimes a bit hard to use, sometimes a bit slow. But this is just this is just prosumer. This is just commercial software, which is really expensive usually. Pro level stuff is nice.
So is that the filament testing again topic that you have?
No, filament testing again is also something else I didn't do for quite a while. So the last kind of filament test was testing some resin. Yeah, was testing this tough resin just around Christmas. But I haven't been doing something like that in this direction for quite a while, and I thought it's finally time to do something again. And I also posted a picture just a couple of hours ago where the filament I'm currently testing actually ruined my fixtures.
Yeah, I saw that. I thought, it's a 3D printed part that you posted that was destroyed, but that was actually not the part that was supposed to break.
No, this was my fixture I usually use to kind of hold my layer adhesion samples. And the layer adhesion with it's actually the Polymaker PC Max, which I'm finally testing. Like maybe many see it as the king of filaments. I have been doing a bit with it in the past, but never really got around to do a proper filament test. But working with it for the last couple of days was really, really nice. And the reason why I wanted to talk about that was, so I did my pre-tests. I did 3D Maker Noob's like temperature setting test towers, which I usually use during my filament tests. And Polymaker is actually recommending to print the material without any part cooling fan.
Which makes sense for polycarbonate, yeah.
Which makes sense for polycarbonate. But I still ran one of the test towers with no fan, 15% fan, 30% fan, 50% fan, and 100% fan setting. And the thing was, no fan, you were able to see that the print quality wasn't just 100% perfect. It wasn't 100% perfect, but already with like 15% fan, it got way better. So I thought about how should I actually proceed? Because the thing is, if you use that material, you're usually using it for mechanical parts.
Yeah.
And I asked myself, how different are actually the strength results, especially layer adhesion, if I just use a tiny amount of fan and maybe increase temperatures a little bit, instead of using lower temperatures and printing with no fan. So what I did, I printed test samples at 250 degrees Celsius without any fan, which also looked kind of nice. Then 270 degrees Celsius, which is kind of the optimal printing temperature for that material. And then 270 degrees with 15% fan turned on. So my question was, is the 250 degrees Celsius part stronger or weaker than the 270 degrees part with just a little bit of cooling? And the thing is, the effect is pretty big. So even at 270 degrees Celsius, if you just add a tiny bit of part cooling, your strength or your layer adhesion will be like 20 or 30% lower.
Yeah.
And this is not even the 100% fan I usually use for PLA parts.
Yeah, but that you're saying, okay, strength dropped considerably, but it looked so much better print quality wise. And that's also been something that I've been struggling with my filament testing is, how do you print your stuff? What I usually ended up doing is printing it the way the manufacturer recommends.
Yeah.
They should know best. But there's always that asterisk that I had to pretty much every single filament test is, okay, you can use more fan for cleaner prints, but for weaker prints, or print hotter and use less fan for stronger parts. That's got to be something that's always a scale on how strong material is. It's not like a single value. So what are you going to end up doing there?
So the thing was, 250 degrees Celsius nozzle looked already way better than 270 degrees Celsius. And 250 degrees without fan looked kind of similar to 270 degrees with fan. And my question was, which is better? So I will now probably use no fan at all and print at 250 degrees Celsius. And the thing also was that the strength between 250 degrees Celsius and 270 degrees Celsius was kind of the same, which is cool. So
Both
I don't
no
have...
fan. Yeah.
Both no fan, yeah, exactly. So the takeaway for me is that I think it will be kind of an interesting investigation in the future to test the influence of part cooling on layer adhesion for a couple of materials. And so part cooling usually decreases layer adhesion and temperature increases layer adhesion. So is there a sweet spot for PETG or PLA in terms of maybe printing a little bit cooler, but also with less fan, or printing hotter with more fan? So where is the sweet spot of print quality and layer adhesion?
Yeah, you may end up with a curve, obviously.
Pareto, yeah.
Where there's no like one definitive spot where both are at their maximum.
Yeah.
And it's probably going to be pretty specific for that one single filament, but I'm thinking you can then take that curve, measure 2 data points for any other filament and match that to that curve and kind of assess, okay, I'm here, and I actually want to be there when it comes to my settings.
I think it's also just good for the understanding of people that they know how much part cooling could actually influence the strength of their parts. And if they have specific application where part strength is way more important than the look of the parts, that they should maybe think about if these parts can actually be printed without fan or way less fan than the standard parameter they are using, because usually printing parameters or profiles, as many call them, have the fan turned on all the way, because that gives you usually the nicest parts.
Yeah, most people test for quality because you can test that with your eyes, literally. But strength is something that testing it objectively is kind of hard. Doing it repeatedly or repeatably. The other thing, of course, that influences strength versus looks is stuff like print speeds and extrusion multipliers in particular.
Oh, yes. I am thinking about getting one of these like DOE, design of experiment softwares, and really make a big DOE how to find the perfect printing parameter.
So you're basically just doing machine learning at that point.
It's not really machine learning, it's statistics in the background.
Well, it's what people tend to call machine learning.
Yeah, exactly. The software will suggest different combinations of all the parameters you put in there.
Yeah.
And depending on the change of the output, so for example, in my case, strength or looks, it can then predict, so interpolate or extrapolate between these points in order to find the sweet spot you're looking for. Yep. And this can be pretty complex, especially if you're doing something like a full factorial design, which kind of blows up every design of experiments analysis heavily. But if you use these software tools properly, they can help you tremendously to get an understanding of, for example, the strength of a part depending on different parameters, printing parameters, with only like 20 samples or something like that. And this is pretty cool. And I have seen that done in the past, and I would really like to do that in the future, because I think it's an interesting topic, especially for also other engineers, because this is a tool and an approach you can use for so many different things, and you just need to know how to apply it.
Yeah. I guess if people listening don't really know what that entire thing comes down to, is maybe if you've seen like car engine maps, it's basically that, where you have, a few outputs that you want to control, and you have a few inputs that you can measure, and you want to find the optimum there. You don't just have like a two-dimensional graph for, okay, this is the input or this is what I can measure and this is what I should do. It then becomes two-dimensional, where you have like those nice colorful maps. Then you have three-dimensional, which is that. And it's past three-dimensional. It's pretty hard to make sense of it. But like the DOE software helps you find like specific spots in that space, essentially, to test for, and then can predict the rest. Right.
Yeah. If anyone is interested in that direction, take a look at Minitab, which is one of the tools we use at work for that purpose. It's a commercial product. It's pretty expensive, but if you have problems in like a company, it can help you tremendously to figure out how things work and find the optimum way more efficiently. There are free things also around. The programming language R, I think, is also R. It's also specifically designed to do design of experiments and statistics and things like these, but you don't have a nice GUI, a nice wizard or things like that, which makes it way more usable if you don't have a degree in statistics.
Yeah. All right. Should we start moving on to the news section?
Yes, we can.
Let's skip 1-2 topics and save them for the next time.
Yes.
News. So today is Sunday, July 14th, and I think the thing that's blowing up on Twitter, or at least the thing that I'm really getting excited about, is 3D Maker Noob has puppies. His dog Bella had 6 puppies this morning.
So you talked to him at Maker Faire.
Yeah.
He also adopted he adopted a dog.
Yeah. Okay. Yeah. Also Bella, my dog's also called Bella. They're pretty similar size. But his Bella is not even a year old.
Okay.
I think. And apparently he got her already pregnant, but didn't know. Dogs are only pregnant for 2 months.
Okay.
So it doesn't take a whole long time for the puppies to actually pop out. But he's now proud owner, proud doggy daddy of 7 dogs in total.
It's gonna be really interesting. Well, a good thing for him that he is also now doing like YouTube full time and is at home most of the time.
Yeah, I think his pinned post on Twitter is actually, "Hey, if you actually want to hire me for 3D printing stuff, you can do that."
Yeah.
And I've talked to him, maybe doing some script writing of stuff we both tested. Maybe that can kind of ease the transition for him.
Yeah.
But yeah, it's good to see more people move full time or move full time towards what they love doing, and you've been kind of inching towards that too. Right? Yeah.
I'm a part-time YouTuber now, just working for 4 days a week. But
you're doing one day YouTube
job.
in 4 days.
Like I do 3 days YouTube and 4 days normal work.
7 days.
There is not really that much like spare time at the moment, which is something I really miss from time to time. It's stressing me out. But you just, I need to produce stuff. I need to get videos out. And since my videos take a lot of time, I kind of work quite a lot at the moment.
Yeah, but you mentioned, I don't know if while we were recording or before that, you're going to have a summer vacation, so you're actually going to take time off, right?
Yes, so in not even 5 weeks, we'll be flying to Japan for 20 days, something like that. Yeah, I've been in Asia a couple of times before, so like the standard Thailand, I've been to Vietnam, I've been to Singapore, but I've never been to Japan, and I kind of fell in love with sushi a couple of, like 1 or 2 years ago. And Japan is kind of an interesting country, and it's getting more and more touristic over the last couple of years. Also because the yen is not worth that much anymore. So it's not that expensive anymore to go to Japan. It's still kind of expensive, but it's more affordable than it used to be. Yeah, and I'm really looking forward to get a glimpse of the culture there. I think it's crazy there, being in one of these big cities. I'm usually not a big city guy, but I loved New York when we were there like 2 years ago or something like that. It's a great city, and I don't know, Tokyo. We'll see. It's gonna be hot, I think.
Yeah. Cities in general, I think that they're nice to visit, but wouldn't want to live in one.
Yeah, you're right.
Yeah, and Asia is still like something that I haven't seen.
Seriously,
I still need to go. I don't know, Taiwan, the Hong Kong area is, I think, really interesting, especially in the world that we live in. In our kind of filter bubble. Hong Kong, Shenzhen, that entire area. But yeah,
I always enjoyed it there. So I was in Thailand 12 years ago, I think. It's now, I think, something where you shouldn't really go because it's just too crowded. Vietnam was 5 years ago, and the cool thing there was that we were traveling with a real Vietnamese guy, so a co-student of mine or a colleague of mine, and the nice thing about that is that you get a hold of the culture in a whole different way, because you don't get ripped off during taxi rides. You get really authentic food there. You live with the families. It was such a great experience being there.
Oh yeah. Well,
yeah. So you gotta go to Asia once.
Yeah. When I'm older and I have some time. That's what we always say, right?
Yeah. Another point in the news section is, well, I phrased it in a way, why have resin printers become so popular during...
And you put popular in air quotes, actually.
Yeah, because
Or in quotes.
In
I mean,
quotes.
it's not air quotes when it's written down, right?
I put popular in quote marks because popular in the way that manufacturers are pushing a lot of really cheap resin printers on the market during the last couple of months and during the last weeks. If you are following Facebook or YouTube, you've seen reviews of the Edelkrone Mars, the what's the name of the printer that Joe's also testing from the Polish guys, the Zortrax? Is it the Zortrax?
The Zortrax, yeah. What's it called? Not the Photon.
Yeah.
Is it?
No, it's not the Photon.
Photon is a different one.
I just have the impression that resin printers are kind of
the new hot thing.
The new hot thing, and I don't really understand why.
What do you mean? Like in general, why are they so perceived popular, or why now?
Well,
because resin printers have been around for a while, for many years, maybe slightly differently built with the DLP projector, but
well,
they've been around.
Yeah, they have been more expensive in the past. So, how's your DLP printer called, or MSLA?
The one hot duplicator.
The one hot duplicator. This thing is $500 to $700, so it's quite expensive.
Somewhere around that,
but the new ones, they're starting at $200.
Yeah, the Mars is somewhere like $229 or something, plus shipping and taxes and imports and all that, of course. But one of the cheapest ways to get into 3D printing, other than an Ender 3 or an Ender 8, which I don't think, but is, I mean, I think it's a few things kind of coming together. Formlabs have managed to make resin printing usable and accepted as like a trusted source of manufacturing stuff.
Yeah.
Prusa, of course, have built up some hype with the SL1. Cheap resin printers have kind of always been around, but now also with that entire ecosystem of what the software is going to be and how the machine itself works, kind of maturing. That's playing into it, and also the printers we're seeing now. I think the Mars as well are all LCD printers, so MSLA, as you would call it, which is not the old. You have a DLP array that shines light onto a vat, but you actually have a phone LCD, a literal phone screen on the bottom of the vat that then blocks UV light. And phone screens have just become really ubiquitous and cheap and easy to address outside of actual phones. So I think that those are all things that just come together right now and make up the fact that resin printers are just super cheap, and it's an ecosystem that is not that new anymore, where you're not going to be able to find resin or replacement FEP sheets or all the consumables. It's just really readily available now.
And that's on the one hand a really nice thing, because resin printing has its upsides, but I am still not a huge fan of it. I see it good for specific applications where you want to have high details and things like these, but it's, in my opinion, just way more dangerous and, dangerous for your health than FDM 3D printing, just due to the resins being really nasty. And I don't know if this is always addressed in a proper way.
It is rarely addressed in a proper way, yeah. I think I also talked about this with Joel and Joe on the last episode, kind of why we have FDM printers as the most popular standard and not SLA or resin printers. And we kind of settled into where I pointed out that, the waste you're getting with FDM is just like little cold chunks of filament that fly around, like filament.
Yeah.
Hairs, essentially, that are going to be around. With resin, it's literally sticky, toxic, uncured resin that gets everywhere.
And I even see people pouring that down a drain.
Ooh, yeah, no, that's a big no-no.
How do you get rid of that stuff? So are some things which are just not as nice to handle as with FDM 3D printing. So yeah, so I think it's nice that they are becoming more affordable, but I see kind of a danger for the people that are using that, and also kind of a danger for the environment, because the stuff is kind of nasty.
Yeah, and you have to keep in mind, like, even the washed, the isopropyl alcohol that you may use to wash your resin parts, that is then also contaminated. You can't just pour that down the drain. I guess let the isopropyl evaporate and then let the resin cure, and then it's in a state where it can be somewhat disposed. But would you throw that into your waste, into the energetically what's it called? Energetisch verwertete, also the stuff that gets burnt for energy. Can you actually burn resin parts cleanly, or it's just it's a whole kind of Pandora's box that you're opening up with resins.
So we're both, I think, FDM aficionados. So I don't see myself.
It's good enough, right? It does it does the job. Resin for me is kind of like these brackets. They really look nice. They look cool, but in essence, they're not, not necessarily better than what we have.
Yeah,
you don't need them. Yeah. But again, that's our viewpoint, and the SLI printers certainly have their applications in high detail and very clean prints.
Yeah. So you have a short story to tell about the Edelkrone Mars?
Well, it's
just
not
an interesting thing.
Yeah. So Edelkrone Mars, they are at RepRap Pro on Twitter. And if you can know the history of the RepRap Pro name, that used to be Adrian Boyer's business, essentially. So his business of, selling 3D printers, the Fisher Delta comes to mind. That used to be RepRap Pro, and that business eventually got sold to a Chinese brand, which I guess is now Edelkrone. So yeah, the Edelkrone Mars, I guess, kind of is grown out of Adrian Boyer's work. He's not involved in the business anymore, I believe, but it kind of came out of that.
Yeah.
So just on the background of the company, kind of.
All right. The next thing, which has been on Twitter for the last couple of weeks, is, if you guys know the fabric 3D printing or printing parts on meshes, this is something which David Shoreys, I think, from Shoreys Design, is doing quite a lot. And I actually met him at Murph.
Yes.
And he gave me something which is somewhere back there, and he's doing pretty cool things. So he has been doing lots with printing things on meshes, on mosquito meshes, and making them flexible. But he has been starting with printing directly on diffraction grating sheets.
Yeah.
So diffraction grating sheets are used to kind of what are they used for? Split up light into it. It's kind of working like a prism.
You might know them from physics class, where you can generate interference patterns with them. Where you can demonstrate constructive and destructive interference, and you can do that stuff. But I don't know where they're actually used in products or science stuff.
So these diffraction grating sheets are thin sheets of plastic which have a microstructure on there. And I first learned about those when I watched one of these how to make your own gecko tape videos on YouTube, where some guy... So gecko tape is the thing that kind of sticks to everything, but it's not using a glue. It's just using intermolecular, but kind of
Right, it's not an adhesive.
Yeah, it's just not an adhesive. It's just sticks.
Essentially mechanic or
Just like geckos can stick to your walls and roofs and something like that, without having like a slimy thing on their feet. And so this guy was pouring silicone on diffraction grating sheets, which then left this diffraction grating pattern, which is really just a very, very tiny structure on the silicone, and then kind of worked in a way as gecko tape. But David is now printing on these diffraction grating sheets, and it is just amazing to see that if you take a look at the first layer, or if you take a look at the back of your print, that you get these how do you say, these rainbow colors.
Yeah, it's like an oil slick kind of reflective, shiny surface. And it's kind of the opposite of what Prusa are doing with her structured sheets, where you want like a rough surface. It's actually really glossy looking surface, but it has that rainbow effect to it. There's a word for it.
Yeah,
I guess it's diffraction.
So if you guys are interested in what he's doing, check his Twitter account. It's at Shory Designs. Really impressive to see.
Yeah, and I guess something you can do at home. Those sheets are, I guess, available.
Yeah, they're available.
Do you know if they're glass or if they're like a polyester or something?
They are polymer sheets. They're not glass. Okay. I think maybe the mold that they're using has also this really tiny structure on there. I don't know how it's done, but I think actually even the guy that did this DIY gecko tape had scanning electron microscope pictures of how these diffraction grating sheets look like. And it's just like lots of small prisms next to each other, but in the nanometer scale.
Yeah, I mean, if you get the rainbow effect, I guess you would need to be somewhere in the same ballpark size-wise as light. So somewhere in the, half a micrometer, 500 nanometer kind of range.
Yeah,
which is actually tiny.
Yeah, it's really tiny. All right.
Yeah, but it's still impressive to see that actually transfers to 3D printed parts, to just smearing a polymer goop over it at that scale. It looks like you're literally just taking a big old goopy thing. But
I wasn't aware that the normal polymers we use for 3D printing are kind of that fine that they can like just make a perfect cast of that structure. I thought silicone was something which is going into that direction, where you can really make imprints of micrometer or even nanometer structures.
Yeah. Well, I guess the half micrometer scale isn't like compared to how large a molecule of PLAs and stuff is. It probably isn't that small, but yeah, nice stuff. Should we move on to the topic of the week?
Yes.
Which is something that you actually don't have, but I do. Just following up on the Edelkrone Wattag Flex Tilt Head 3D, which I did make a video on, and it's a camera head that you partially get to print at home. And I don't know if Edelkrone actually see it as a real business thing, or if it's just a marketing stunt selling that for cheap. But compared to the off-the-shelf, they do have an off-the-shelf aluminum machine version, which is 149 euros. They're selling the kit for the DIY version for 29 euros. So 1/5 of that price. And the idea is you get all the parts you can't really make at home, or can't 3D print at home, as a nicely made kit, and you print like the bulk of the parts, but literally bulky parts that don't need any sort of precision or any sort of specific material properties to them. So that's something that I don't think any other manufacturer has done, or let's put it like that, any well-known big manufacturer, because Edelkrone are kind of a premium camera accessory. They make sliders for hundreds of dollars. They make innovative camera heads like that, and those sort of things, but all very high quality, well-made stuff. I don't think anyone else has done it that way.
Yeah.
And the question is going to be, is that actually something that we're going to be seeing more of the idea that you can make spare parts at home. You can essentially print the product at home with just a few augmented parts. So, yeah, I mean, the one other thing that I know is that, I don't know if that's still a thing, but some manufacturers tried to have like a bit of a parts library online. When it comes to like washing machine dials or small stuff like that. I don't know. Have you seen anything like that?
I think I've seen already something like that, but I can't really remember. Well, 3D printer kits from time to time.
Well, yeah,
where you have the printed parts. But yeah, this is still in the same regime. I also find it really interesting what they're doing, especially in terms of warranty is not the right word, but who is to blame if you drop your 1,500 euro camera because you printed the parts in the wrong way, or something like that.
Well, they do kind of they do insure themselves against that by saying, okay, we have approved printers like the Ultimaker S5 and the Ultimaker 3 and the ZX. Those are the printers that we actually approve. That we know are going to get good results. And please print at 90 to 100% infill. And then they rate the entire head for a 2 kilogram camera, which is very, very conservative. Like it's not nearly to the point where it might snap or where it might break. If you put like 100 grams more on it, you could probably put 20 kilograms on there. And the only thing that would happen is that the joints aren't tight enough that the camera would sag down. And essentially, you have your tripod, you have the camera on top, it would just go, it would flop down. That's all that would happen. Because the joints themselves are aluminum. Like those are not going to break. So it's always going to stay attached to your tripod.
Yeah, as I said, I think it's really nice, but there's always the problem with customer satisfaction. And you had this nice squirky noise and things like these. If you provide these kids, especially if you are in like a more expensive market, it's hard for you to get everyone happy because not everyone has the proper materials, the proper printers, and all of the things. So how is the reputation of the company affected by these kids if something is not working out? Because you can only do quality control of the separate parts, but not the final product you're usually selling. And I think this is a problem. This could lead to the point that a couple of companies won't do that because they don't want to have their reputation being bad because people printed the parts in the wrong way. I think it's nice, but I still would like to see it more in terms of replacement parts where they can fail and it's easier for people to just get a replacement there. I don't know, what is your take on that? How do you think, do you think it's just a marketing gimmick of Edelkrone, or do you think there's really a business case behind that?
I mean, okay, so what are the main costs for Edelkrone at manufacturing these parts? It's going to be, or for manufacturing these heads, it's going to be R&D. That's going to be a huge one because they don't have the volume to actually make up for it. And yeah, manufacturing itself, machining, those are all CNC machine parts that they're using. And then, of course, by weight, shipping. The heads are somewhat heavy, but just the shipping is going to be minimal. So R&D and manufacturing really they're saving on it. They're saving big on it because it's way less material that they're machining.
But do they save $120?
Say again?
Do they really save $120 on machining?
Probably not. So manufacturing, yeah, slightly. R&D, there's not less R&D involved in an ORTAG head than in the regular one. But I guess they see it as, okay, we've already figured this thing out. Let's strip out a few parts and explore or get into a market that we wouldn't be able to get into with a more expensive head. So I don't know if it's actually a business case, but it certainly is a marketing instrument.
Yeah.
On the topic of, is it possibly going to damage a company's reputation if it doesn't work? I think it's the company's task to actually make sure that it works, even if the print isn't perfect. I'm not sure you can see that a whole lot in the Edelkrone design, but I'm thinking like along the ways of, okay, you have your aluminum parts that need to fit into the 3D printed parts, have some sort of a pattern, like a Torx pattern or something, where it really meshes with the 3D printed part, even if it's not perfectly to size. Allow for some tolerance, or allow your machine parts to take up some tolerance from the 3D printed parts. That just needs to be part of the design of both the machined and the 3D printed parts. But it's also on your topic of, are these printed parts always going to work? Just saying, okay, we'll just print replacement parts then. But for replacement parts, we have, I think, even stricter requirements for tolerances, because you're usually replacing an injector molded part with a 3D printed part.
Yeah.
So I think it's easier to make a virgin product that is a fab at home version versus just replacing some random part that may not even be designed for 3D printing with a 3D printed part down the road.
Yeah, you're probably right there. And well, they put some thoughts into designing this head, or well, the printable parts of this head, as far as I've seen from what you've been telling in your video.
They're very well designed for 3D printing.
They specifically designed this for 3D printing. So this is a good thing. And they didn't just say, okay, here are the CAD files of the standard part, print them out. They really tried to make sure that it's possible to be 3D printed. So if we would have more thought out products in this direction, it might be a really good thing if it makes them more affordable for us. But it's not that simple. You need to put some more R&D and really, well, creating one of these parts. And I don't really know if they are making that much money with a $30 3D printed kit, because
I don't think,
if you think about how much, where are they actually located? Are they
Turkey?
Okay. But the cost for mass manufacturing of aluminum parts, it's cheap. It's really cheap. So maybe the standard parts that are delivered with like the 150 euro fully assembled version, maybe there are 20 or 30 bucks in the end. I don't know. I can't really judge it because I don't really know what the difference is. But the thing is that I think they are making a profit with the standard version, but I think the other one is just a gimmick at the moment. And if you really want to make a business case out of such a thing, you need to charge a certain amount of money for the R&D for creating the other parts that are also on the standard version and things like that.
Yeah. Now, okay, the thing that I'm seeing here is in the ORTAC line, I don't think it's intended to actually compete with their premium, with their regular product.
Yeah.
I mean, I guess if you really printed it right, and I've seen some comments that say, okay, if you use a nylon, just print the parts with a carbon fiber nylon, it doesn't squeak, it grips better, it works better. But still, it's a 3D printed product that you have to print and assemble yourself. If you're actually running a video production, you're not gonna flinch at a 150 euro tripod head.
Nope.
First of all, you wouldn't buy it; you would rent it. But also, it's like that sort of money is nothing in a big production. So it's not gonna push their other products out of the profitable markets. But maybe they're seeing a bit of a venue with the actual modifications that people can do, because that was something that wasn't really clear with at the time that I recorded and scripted the video. But I've clarified the license situation with Edelkrone, and they're actually putting out the design files on a very liberal license. On Thingiverse, it's Creative Commons attribution share alike. And they've also sent me their own Edelkrone attribution license, I think it's called, which essentially is Creative Commons attribution share alike, with, in the spirit of the license. So, like I've mentioned in the video, I think it's that there's so many more possibilities on the end user side of just using that parts kit and creating your own design with it.
Yeah.
Based on that precision kit.
Yeah. So you're right. It's probably opening a totally different market for people that wouldn't buy such a thing in the first place, but they know now by the high quality parts in between that they need to then create something for their own application.
Yeah, and
it's maybe even competing with Chinese knockoffs. I don't know. So the question is, if there is a Chinese knockoff that is $50 for the standard aluminum version, or a maker can get a Edelkrone 3D printable version for $30, maybe you could convince a couple of people to buy the genuine parts in between and then use their existing 3D printer to print the rest. And they are still kind of saving something if you don't take like working hours or the wealth of your own time into that calculation.
I mean, you can get like really simple knockoffs for $20.
Okay.
Which have like one less platform. So they're just like 1V platform, I think. So that takes away a bit of the functionality. And then you can get like a more expensive one, which is still that 2 platforms, but I think a different manufacturer. So yeah, the Edelkrone kit is kind of in that same price bracket as the knockoffs. Where was going to go with this?
Well, anyways,
so I think the sharing and modifying these designs, that's also something that just gets the name Edelkrone out.
Yeah.
If there's actually a community growing that uses those parts, which right now is a bit limited in what you can get, to build camera rigs and to build heads and kinematic stuff for cameras or for other stuff, then everyone's going to be using the Edelkrone parts.
Yeah.
And that just gets the name out.
Yeah. The thing which got me interested in when I watched your video was that you said that it's way lighter than the aluminum one. And I thought, okay, I'll be on holiday with maybe just a backpack in a couple of weeks. Would this be something I'd rather take with me instead of the heavy aluminum version? I don't actually know what the use case for something like that is, but this could be the decision for me to buy one of these kits and 3D print it out and take it with me on a trip if I would know for what I would use it.
So the head, the use case for this specific head, I don't think it's. I make it very clear in the video, but there's a good video on from Edelkrone that kind of explains why you would buy this. Is you have their sliders, and with a slider, if you slide like along the axis of the slider, at some point you're going to see the slider in the shot. So that head just lets you prop up the camera, or it lets you extend the camera forward, so it slides past the slider rail. It's really a slider accessory.
Okay.
In its core, you can use it, in place of a ball head somewhere, but it's made for that. But weight for traveling definitely is a point. Now, the thing that I was going to say just before, where I forgot what I was going to say is, why aren't Edelkrone printing these themselves? Why aren't they using 3D printing for manufacturing their heads? No. Is it because it's not actually producing a product that they would be happy selling because they don't like the 3D printed look? I don't know. Or because there's other issues with consistency that they've run into, or is it just not worth it for them to run a 3D printer line to like in bulk manufacture these parts and then provide a kit for, I don't know, $39 with the printed parts?
That's a really good question. In my opinion, it is aluminum machining is just horribly cheap. So I don't think they really pay that much for the aluminum parts. And the consistency of the product in the end, and the quality of it, and the usability of it, and the rigidity of it, and the durability of it is probably way better with the aluminum parts in comparison to 3D printed ones. The question maybe could also be if they're not 3D printing them because of consistency or other things, might injection molding be a possibility to make a cheaper version?
Right, yeah. Yeah, but of course they need a bit of volume just to pay for the molds.
Exactly.
But yeah.
I don't know. What's your opinion on that? Do you think it would be why do you think they are not printing these parts on their own?
Yeah, I mean, so what you can kind of see is that the rigidity of the entire head is, of course, not as good as the full aluminum version, which kind of surprises no one because it's plastic. It's less rigid than an aluminum part. Robustness and just durability, I don't think is an issue because the printed parts are just so chunky. You could drop the entire thing. You could run into it with other stuff. I don't think that would be much of an issue. But just Edelkrone as their brand have always been a solid aluminum brand. I used to have, or I still have, their old slider, which I've had for 1.5 years or so. It's just like it's an aluminum brick. Their head one, their slider head is also an aluminum brick, and then this shiny acrylic piece laid into for looks. But they've always been about very overbuilt feeling parts.
Yeah, this just separates them from cheaper versions. They want to be this high end brand, and people are expecting that if they are buying that, and if they don't want to get into the cheapo market, this is still a possibility to maybe get in another market, but people don't expect the Edelkrone quality if they are buying maybe the 3D printed kit.
Yeah. And I guess just to put this into perspective, like video gear, cheap is relative and expensive is relative. Like the prices that I'm mentioning, $150 for the flex tilt head for the regular one. For a tripod head that's for video production, for professional video production, that is nothing. Like paying $1,000 for a tripod head, that is considered like a production ready head. Or the slider that costs $600 plus the $400 for the head. That is absolutely nothing when you're looking at the big productions. Yeah. But of course, for like the prosumer and smaller scale production, that is expensive, and that is considered premium equipment, especially compared to like the much cheaper import alternatives.
Yeah.
But that Sachtler tripod, the one that MKBHD has with the one clamp. Do you know that one where you have like the one clamp up top and the legs just extend all the way?
Oh no!
So good, but way too expensive.
So will you be using this one in the future if you also have the aluminum one?
So the first thing I'm going to have to solve is the squeaking issue, because not only is it squeaking, but it's only allowing you to like adjust the camera in really coarse increments, because you build up tension and then it releases with a squeak.
Stick slip effect.
Slip-stick. I never know which way around it is. So that not only is an acoustic problem, which is of course what's generating that sound, but also a usability issue where you can't really adjust the camera finely. Which kind of makes it pointless. The other thing is also on the usability side. I like to have my sliders on an angle, so where a print kind of builds up, the camera rises along with it. And the flex tilt head doesn't allow you to tilt the camera.
Okay.
So it's always going to be parallel to the surface that it's riding on.
Yeah.
So your shot is always going to be crooked.
Yeah.
So I'm going to have to find use cases for it. In general, though, if that stick slip issue wasn't there, I would not have an issue using that over the aluminum version.
Cool.
At all. Like I think if it's just as smooth, I would use it with no regrets, no limitations.
Cool.
Because my cameras are relatively light. They don't touch that 2 kilogram limit.
What's a GH5 actually?
I think it's like 736 grams.
Okay. Just don't put a tele lens on that.
Yeah, don't put that 10 to 25. Which is now out, but you can't buy.
Okay.
It's like a
because it's sold out, or
I don't think it's been shipped to resellers yet.
Okay. All right. Nice. I
725 grams.
725. Okay. Yeah, that's pretty light.
Plus lens. Yeah, so way lighter than. But yeah, it's the product itself, the Ortec Flex Tilt Head 3D by Edelkrone. It's a viable product, I think. If you're willing to put the time and the printing into it. Of course, that entire thing of, okay, you can customize it. You can print it in your own color. You can use different filaments. Like there's going to be one filament type that works, that doesn't squeak, which is probably going to be the nylons, the fiber reinforced stuff, possibly. Color-wise, do you care about the color of your video equipment? Not really. Everything's black. I don't know, and showing up on set or for a job with a turquoise tripod head, not sure how well that would go over, but
yeah,
I'm really seeing more potential in the actual geometry customization that people can do, and they do provide SolidWorks files and step files, so you can actually modify them. It's not like they're just throwing out the STL files and going like, okay, do with it whatever you want.
Yeah. No, that's pretty nice for the community because, well, there are certain applications where they probably didn't even think about before. If you have this swarm intelligence of so many people that are around and would like to use it, there might be some really cool use cases for the parts, or it's just some customization work on fixing the issues it has at the moment, like the squeaking and whatever.
Yeah. And I mean, we've seen with 3D printers that definitely works if there's a liberal license attached to it, which the Edelkrone parts do have.
Yeah.
So yeah, like I said, I really respect them for taking this step, and I think for them it's really a big experiment and a big venture into the void, into the unknown.
Yeah.
I wish more companies would do that just to try it out. I don't think it's a huge risk for them. They've put the hours to design the part. And yeah, I don't think it's chewing into their markets or into their other products sales. So yeah, again, I would really like to see more companies do that, just for the sake of being able to slightly mod the parts and for having kind of that library of, okay, I need a friction joint. Oh, here's that. I need a mount. Here's that part that I can use.
All right.
Yeah.
Do we have any questions?
I'm looking at our notes, and we do not have any questions, I think.
And we are already 1 hour, 30 minutes in, so...
Yeah, that's what happens when we don't talk for a month.
Yeah. And we skipped so many points we also had on the list.
One of the questions that people had when I started my channel and was like, okay, I'm gonna do this full time now because that's what I kind of have to do now, is, hey, are you actually gonna have enough topics? And I was like, I think I'll be fine.
Yeah,
I think I'll be fine. We had the same thought with this podcast, but so far we haven't run out of topics.
No, we did not. All right, so I think that concludes it for today, doesn't it?
Yeah. So thank you to Skillshare for sponsoring both our last videos, but not this podcast.
Not this podcast, yeah.
Thank you all for watching or listening.
Definitely.
Where can people subscribe?
Everywhere. We are in Spotify. We are in basically any podcast player. We are on iTunes. We are on YouTube. Google Podcast. You have to download our episodes. You can't stream them. I still don't know why, but that's the case.
Something's going wrong there, yeah. And it looks like something is going wrong with my microphone, so please excuse that if my mic has been having some issues this episode. But thank you all for listening. Thank you all for watching, and we will catch you all in the next one.
Yes.
Thanks, Stefan.
Thank you, Tom. Goodbye.
Bye-bye.